Hello everybody, welcome back. So far we talked about some important concepts like gradient descent, overfit and underfit problems, cost function or regularization. Now I want to talk about neural networks. But before that, if you haven't joined our channel yet, please subscribe. Now I want to start with a discussion of artificial neural networks and how they're inspired by the real-life biological neural network in our own body. Many tasks that involve intelligence, pattern recognition, or object detection are extremely difficult to automate, but seem to be performed easily by animals and young children. For example, your pet can easily recognize you as the owner from a total stranger. Each of us contains a real-life biological neural network that is connected to our nervous system. This network is made of a large number of nerve cells called neurons. Therefore, an artificial neural network is a computation system that attempts to mimic the neural connections in our nerve system. Each node performs a simple computation. Each connection then carries a signal from one node to another, labeled by a weight, indicating the extent to which the signal is amplified or diminished. Having a large positive weights indicating that the signal is very important when making a classification. Others that have negative weights diminishing the strength of the signal, to say that the output of the node is less important. This is the structure of a biological neurons. Neurons are connected to other neurons through their dendrites and terminals. Our brain are composed of approximately 10 billion neurons, each connected to about 10,000 other neurons. The cell body of the neuron is called the soma, where the inputs and outputs connect soma to others. Each neurons receive electronical inputs from other neurons at their dendrites. If these inputs are sufficiently powerful to activate the neuron, then the activated neuron transmits the signal. Neuron firing is a binary operation. The neuron either fires or it doesn't fire. A neuron will only fire if the total signal received at the soma exceeds a given threshold. The goal of deep learning is not to mimic our brain's function. In fact, we just take the inspiration. Now that you see the structure of a biological neuron, I want to show you the architecture of a basic artificial neural network. This artificial neural network performs a simple weighted summation of the inputs. It takes the weighted sum of the input x and weights w. This weighted sum is then passed through the activation function to determine if the neuron fires. x1, x2, and x3 are the inputs, and 1 is our bias term that I'm gonna explain it later. In practice, these inputs could be vectors used to quantify the contents of an image. For each input, we also have an associated weight w. Finally, the output node on the right takes the weighted sum, applies an activation function, and outputs a value. Alright, now that you know the basics of neural networks, next session I'm going to teach you activation functions. By the way, we start to code deep learning soon, so if you don't know Python, start to learn it from our Python course in this channel or any other sources you want, so that you don't get to any trouble when we start to code. You have to know activation functions really well so that you can use them properly in your model. So don't miss next session. If you enjoyed this video, please like us. And if you haven't subscribed yet, please subscribe our channel and turn on the notification bell so whenever I publish the video, you will be notified.